All right, I think we're recording. Welcome to How to Use Primer Blast. And it's going to be a little different than what I showed in class, but it's another option. And I'll show you why our brain is better than computer. Okay, no. So let me share my screen. Of course, it's always a problem for me. All right. Oh, there's my screen. All right, here's my little head. Put my little head right there. Make my head a little bit. Oh, hello, my head is. All right, guys, so we're going to type in NCBI Primer Blast, like so. Then we're going to click that. It's going to bring us to a page called Primer Blast. Shocking, I know. And we are going to take our sequence and we are going to put it into our PCR template. So that would be the sequence we have from our little Word document. So copy and paste that guy right into your PCR template. So I just copy and paste it right here. We are going to ask the computer to make primers for us, but we're going to set up parameters for which it needs to do that. So what do I mean by it? I mean, we can't just say, make some primers, because otherwise they're going to make a small little piece that's not going to be helpful. Remember, we want everything in our 5' UTR. So we really want it sitting right down here close to that ATG. So what we're going to do for that reverse primer, remember this is the guy going that way, we're going to say we want it to be between 930 and 969. Now, I think this guy tells us somewhere it's like 969 base pairs, or I don't know how that was on my other file. So anyways, right here should be 969, the C, and then 930, that gives us like 40 base pairs. Because again, we don't want it way up here. We want it to sit right down here somewhere. And then the forward primer, the guy right up on the top of our sequence, which I can scroll. Whoa, hello. That we can have way up here. We only need about 500 base pairs. I mean, ideally we'd get more, 800 or 900, but if we have to, we could just get the 500. So let's say the forward primer can sit anywhere from that very first one, the farthest away, this 5' end, all the way to about 500 base pairs. So if our total is 950, that's still 450 base pairs. We can always make this smaller, but let's give ourselves a nice big area. This is a small area to find a good primer to match something in this big area. So we ignore this. This is if we have our own primer, which we don't this time. And the rest of these we're going to leave at the default. Right? Yes, yes, we're in Homo sapiens, blah, blah, blah. Mismatches to other targets. We can make that. We'll talk about that in a minute. And then we're going to say get primer. So click get primers. It'll take a couple minutes. What you'll see, when it comes back after about a minute or so, is a graphical view of your primer pairs. And so as you can see down here, here's all our 3' reverse primers. And here are all our 5' primers. So you can see a lot of them sit around the same area. One is that this would be the biggest one. And all of our 3' primes, so I'm not sure why this is highlighted. I'm not sure what the deal is, but let's make that head go away. This line right here, this red line, not the one attached here, this far red line here is the end of our sequence. So that ATG, so the 969. So we don't really want the primers that are pretty far away. Right? So there we can see where they are, what their deal is. We kind of want the ones that are closest to this line. And that would be this guy, and this guy. Okay. So this guy is not quite as close as this guy and this guy. He sits a little farther, but the primer 7's way out here. So it would be a potential possibility to try. So the reason it's highlighted. So if you pick this one, if you click on that guy, right, it'll give you the sequence. It'll tell you where it sits. If you look, we can see that it's melting, its melting temperature is pretty similar. Okay. Oh, there we go. Sorry. So, right, you can see this guy's pretty close. That guy's not as close, not as close. This is the guy that's the closest. That's why I clicked it. And you can see its TM, melting temperature, is really close, even though the GC percentages of them are totally off and they're not the same size primers. You can see, right, 20 base pairs versus 16, and it makes a PCR product of 519. So it's more than our 500 base pairs. So if you click details right there, that will give you the details of that primer pair number 4. So here we are again. Remember, it was 20 and 16. This is where it starts and stops. So that's on the 5' side. And this is on the 3' side. So 65, that's pretty close to the end, that's 69. So it's got to be sitting there kind of like the primer that we made in class. GC rich, that's crazy, but the melting temperatures, how, you know, that calculation ends up being very similar. So that should be good for PCR. Here's our, and then just to be sure, right, plus and minus, if they're both on plus, they're gonna go like this, both on minus, they're gonna go like that. Okay, won't make a pair on this if it is, but just helps us, you know, that's what that means. And so then this program also shows us unintended templates. So it's gonna sit on this transcript variant of the supervillain. Maybe we want a PCR supervillain. And here's what it looks like, the template where there's mismatches. So it's not super close, but it's okay. This one, you know, there's only mismatches in 3 places. And it's gonna give us a product of 3,600 base pairs. So that's nowhere near our 500 base pairs. So unless that template sucks up all of our primers, so none of them sits on ours, which is 100% homologous complementary base pairing, might happen, shouldn't. This band won't confuse us because it'll be huge on the gel. It'll be nowhere near our 500 base pairs. So it could still be fine, okay? This one's too very large, 3,500, 36, 36. Super villain. It is a super villain. It's gonna suck up our primers. My primers. You guys don't have to worry about that. Another different gene, right? 2,300, still very large, not gonna get in our way. 2,300, 2,300, blah, blah, blah. Okay, down to this guy. And then we move into that next primer pair. So we could say, okay, it's possible to sit on these. We know if we see sizes that big, not to panic. Or we could go ahead and pick another primer pair and see if there's less, you know, anti-priming. Oh no, that's sorry. What's this? Oh, okay, here we are. So, oh no, that's the wrong one. I've lost my, okay. So for example, if we, my head's in the way again. If we look, what was the other guy we liked? We're looking for the guys closest. That guy's close. He's farther. He's farther. I think he's a little closer. Let's just go for him, right? Why not? Let's click him. Oops. There we go. Hit details. Gonna open us another. Hello. Uh-oh. Where'd he go? Primer pair 9. Is that the pair we wanted? Yeah. Oh. Our melting temperature not as good for this one, right? Not as close. Pretty close, but not as close. Self-complementarity, I'd have to look up what those numbers mean. I can't remember if those numbers are good or bad. Product length about 500 again, so that's okay. This guy sits 64 to 498, so remember that is a little farther, but pretty good, right? That's pretty much right there. And then where else does it sit? This guy sits on a transcription factor. Again, these are the mismatches it's going to show. Oh, but the product here is going to be about 500. So that kind of sucks, right? 500, we won't know, did we get the right thing or the wrong thing? We won't know until we clone and sequence. So that automatically, for me, total deal breaker. So in your face, primer 9. Let's go back to 7. That guy was close. GC is close. Melting temperatures are close. Here we go. La, 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 la. Right, all that reverse primer is all sitting about right in the same place because it's very close to being the same exact primer, the one that I chose. And then where it's going to sit, again, this guy's going to sit in a G protein coupled receptor guy, like blah, 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 RNA. 1500, that's big. 1500, that's big. Yikes. 628, 550 to 620, you can resolve that, but we kind of just want to look at a gel and go, yay, and not have to like measure to the markers and really get crazy. So that makes me a little uncomfortable. It's only 2 mismatch. There's a bunch of mismatch. It should not sit. But in science, what you don't want happening always happens. This is tiny, tiny. That won't interfere. Tiny, 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 tiny. Big, big, big. But there seems to be a lot more of them for this guy than for our other primer pair. So I would say, since our other guy's better. So our favorite guy was 4. Was that this one? Yes, here's our favorite guy. And so if we were asking the computer to do it, this is what we would go for. Okay, so this is 965 to 950. Now, when I went in, oh, my head's in the way. Went in class, again, this was where we put in our 3' primer, the one I designed, and then just asked it to make the 5' primer. So if we looked at primer 1, which is this guy, this big guy out here, then, you know, here's his story. Right, melting temperatures, GC, this melting temperature is closer than that one. That's about the same, that's about, so we can look through all these different pairs and see how good they look. Now let's see if we eyeballed, so they all have the same 3' It's the one we recorded. All right, let's try primer pair 10 because our melting temperature is really close, okay? It's about the closest of all of them. So let's go back up to 10. Is it gonna give me details? Okay, let's see if it'll give me the details. No. So I guess we're gonna have this, okay. So for this one, then we're gonna have to take these primers and then test them ourselves. So it doesn't automatically do it for us. That will be the next tutorial. So for now, that is how to use PrimerBlast to design both primers. So you're more than welcome to do that. And then we can compare to what you eyeballed for your 3' and what the computer tells us. And we'll run a test of these to get those mismatches, just like this program showed us, right? Like this primer pair 4 and all of its potential mismatches, we can actually make that happen for the sets that the computer designed for us. I thought we could click it and it would make it happen, and maybe we can, but I don't know how. So that'll be another tutorial. So thanks guys for listening, and I will talk to you soon. Thanks so much. Oh, stop recording.